Probably steak house. Steak.
Okay. So the first thing you do when you multiply is you check to see if it's possible. And here's how you check. What are the dimensions of this matrix?
4 by 2. 2 by 2.
2 by 2.
Okay.
What are the dimensions of this matrix?
2 by 2.
2 by 2. Now, here is the rule for multiply. For add and subtract, they must match. For multiply, the only thing that has to match is these two. If those two match, you can multiply. And the answer will be a 2 by 2. So, in other words, if I had a 3 by 5 and a 5 by 8, I can multiply them, and my answer would be a 3 by 8. That is the rule for multiplication.
Oh my God! Wow.
Okay. So one more time, we have a 5 by 2 and a 2 by 3. They are multipliable, and the answer will be a
5 by 3.
5 by 3.
If you have like a 5 by 3 or a 5 by 2, you don't know.
Nope.
So
These two have to
yeah,
match.
but what would you write? Just like can't do it.
So you just can't.
You're good, Darby.
Alright, now, here's how it works. We have figured out that our answer is going to be a 2 by 2. Our job is to figure out what these numbers are in here. So we're going to start with this one. What is this number?
6.
This number is in row 1, column 1, correct? Row 1, column 1. So you take the numbers in row 1 and multiply them times the numbers in column 2. So just stop talking and listen, okay? So we take 1 and negative 2, that's row 1. And then we take 6 and 0, that's column 1. And we multiply each pair and add them together. So that is 6 plus 0, which is 6. Now, to fill this one, I would do exactly the same thing. Only that number is in row 1, column 2. So now I'm going to take row 1, which is still 1 and negative 2, that's row 1. And I'm going to pair it up with column 2. Multiply each pair, add them together, and that will be 11. 3 plus 8. All right, let's move down here. Okay. Where's this? This is row
2.
Column
1.
column 1.
Okay, I'm fine.
So row 2, column 1. So I write down 3 and 5 and pair it up with 6 and 0. Multiply them, add, that gives me 18. And then finally, row 2 and column 2.
I'm feeling negative.
And that is 9 minus 20, negative 11.
I'm following. I think it is.
Yes.
We are finished with that problem. Alright, so let's try the next one. It is another multiplication. We are going to multiply.
Wait, multiplication they are. What does it matter?
We multiply, we just did a multiplication problem, and I did through the rules, everybody's paying attention. Not talking, paying attention. So here is matrix B. And here is matrix C. And I am going to, I'm supposed to be multiplying them. But before I start, I'm going to check to see if I even can.
2 by 3, 3 by 2.
Can I multiply?
Yes. Yes.
Yes, because this one is 2 by 3, 2 rows, 3 columns. This one is 3 by 3. And since I am multiplying, the only thing I need those two match? And they do. So the answer will be a 2 by 3. So the answer will look like this. It will have 2 rows and 3 columns. So, how do I fill this spot?
First row.
First row.
First column.
First column. So here's the row. So 2, -1, 3. Here's the column. 1, 0, 1. And then I just do the math. And that will tell me what that number is in that first spot. So what is that? 5? Alright, 2, yep, 5. Alright, now I'm gonna move over here.
Second.
Row 1 to R1, second
Row
column.
1, always Roman Catholic, row first. R, C. So row 1, column 2. So row 1 is 2, -1, 3. Now I'm doing column 2.
-1.
So -1, 3, and 4.
7.
Add them up. And that is 7. Alright, we'll do one more together and then I'm gonna let you do the bottom row by yourself. What is this spot?
5.
Oh, I don't know. It's row 1,
Column 3.
column 3. So row 1 is 2, -1, 3. And column 3 is 2, -1, 0. So when I multiply everything and add them up, it is 5. Alright, now you do the bottom row. So
Nine.
you are gonna do exactly what we just did, except you're gonna be using this, right? Row 2. So you're gonna be using 5, 1, 4.
Wow.
Here's what I got. I don't know if that's right or not.
I got that too.
Does that match? Alright, so we're good on multiplication.
Yeah.
Well, good, because there's one more. A times C. Problem F. A times C.
You can't do it.
Can't do it.
Can't do it.
Because A is 2 by 2 and C is 3 by 3. These do not match, so you cannot multiply. Alright? Now, A transpose times B, that's letter G. Now, A transpose, remember, what does that mean when we transpose? So, look at matrix A. See how row 1 is 1, -2? So column 1 is 1, -2. And then 3, 5. So this is the transpose of A. Everybody okay with that? Row 1 becomes column 1. So whatever row 1 is, 1, -2, it becomes column 1.
So negative, so -2 wouldn't be on the top, it's 1.
Listen, Ronan. What is row 1 of matrix A?
Row 1 is
Row
1
one.
-10.
That becomes column 1. That
Oh,
becomes
so you
column
just keep,
1.
I know, but I thought.
No,
but
no, stop
negative.
thinking. Row 1
Yeah, I was just-
becomes column 1.
Okay.
Okay.
I was just reading for it.
Row 1 becomes column 1. Row 2 becomes column 1. And so on. multiply that
Yes.
times b.
Easy.
Would you flip
So
that?
we got a 2 by 2 and a 2 by 2, we can, and we're gonna get another 2 by
2 by 2.
So let's go ahead, see if you can fill in those blanks.
First row.
Another 2 by 2.
You gotta watch out for that. 6.
Or wait, sorry, I like can't do it like not. It's 1610.
No.
1610 or
Good.
1610?
Should it, got it.
16 and then 10. And then wait, yeah, 16 and 30. I'm sorry. I skipped that part. It was 0. So
Oh, I did. Wait, what is it again? Bro, that's 1, 6, 3, 0, 6. Yeah. And then, what is the next one? 1, 3, 3, 4. Oh, I'm stupid. Oh, we're gonna get.
All right, everybody get the same numbers I did?
Yeah, but my math is long.
Ronan, did you get those numbers? For real?
Yeah, for
All right. Letter H, new concept. We are finding what is called the determinant. The determinant of A. And that is written like this. That means the determinant of A. Now, the notation for the determinant is vertical bars. It looks like an absolute value. And like absolute value, it is just a number.
Good guess.
So the answer to a determinant problem is a single number. All right? Now, how do we find that number? It is very, very easy. In fact, all this stuff is easy. You just have to remember the procedure. So here's the procedure. To evaluate a determinant, you multiply these two together and you get 5. All right?
Yeah.
Then you multiply these two together and you get -6. And then you subtract those two. So it is this diagonal minus this diagonal. So 5 minus
11.
-6.
11.
The determinant is 11. The value of a determinant is always a single number. Now, do B, or I mean, letter I, it's exactly the same thing. What is the determinant of matrix B?
I'm never going
21.
Negative 24.
Negative 20.
What do you get when you multiply the
no, it's
Negative 24.
Negative
Darn.
24 minus
You said
0.
no.
Negative 24 minus 0. So that would be negative 24. Stop it. How do we do a determinant again? We multiply this diagonal, and then we multiply this diagonal, and subtract. Subtract. All right. Now, the determinant of C. Okay, I heard somebody say, oh shoot. Here's the
Because I
deal.
gotta go back and forth on the page right now.
The process is similar but bigger. So we are going to find the determinant of this.
Be all the way across?
Now, keep your guesses. I'm glad you're guessing. Let's keep them in our heads for a minute. Take the first 2 columns. So these are columns, remember. recopy them right outside the determinant. So 1, 0, 1 right here, and negative 1, 3, 4 right here. So these two, right here, these two columns, I am recopying right here. And I'm being really careful to be organized, okay?
Wait,
So
why'd you
things
do
are
that?
lining up.
Why'd you
Because that's
recopy
probably
and
gonna
do
show us that decision. Come on.
Now, to evaluate the determinant, you do what you just did. You start right here, and you multiply all these numbers together. And we get 0. But now, we step over here and we multiply all these together. And we get 1. And then we multiply all these together
Zero.
and get 0. So, we expanded our matrix
It was 1.
because we are going to have to do 3 multiplications.
Just 1.
All right, and that just makes, oh, that makes 1, yeah. That makes 1. Now, you're half done. Now you're going to go the other way. Remember how you did this minus this? That's what you're doing here, only you got 3 of these and then minus 3 of these. So this makes
6.
6. This makes negative 4. And that makes 0. So that adds up to 2. Now, it is, because what do? We take this minus this. So we take all of that, which is 1, minus all of that, which is 2. So our answer is negative 1. That determinant is negative 1.
My goodness. That's a lot. Of like, it's not even hard to organize.
It's just tedious.
I'm also just
All right, last one in part 2 says find the determinant of D.
Copy the first row.
This one is impossible.
Never mind.
You can only find the determinant if the matrix is squared. The
I've only
matrix
been
has
2
to
by
be
2 and 3
squared.
by 3.
2 by 2, 3 by 3, 4 by 4. You cannot find the determinant if it's not squared. So the determinant of D is not possible. There is no determinant for D.
Are we ever gonna get any like big like 5x5s or is that not?
We will do big things, but we will let our calculator do it.
Oh, is
Because
that a function?
literally, let me think for a minute. A 5x5 determinant would involve doing 20 of these. Yeah, it's a lot. So we're not gonna do that. Okay. Problem 3, find the determinant. So now we'll see if you were paying attention. Just did one. But we're gonna do another one. It's just like that. Just like that. So right now, you and your partner start figuring out what the value of this determinant is. And I'll do it too.
I got that too. Fall. Fall.
What?
What?
First you do this side, then you do that side, you multiply these two.
You get 1 over 2.
Then you minus everything.
Huh? I don't even know.
I gotta just remember.
104.
It is really easy to make a careless mistake.
It really
You
is.
you have to be really careful. And honestly, one of the biggest mistakes I see on these is, remember, if you're multiplying by a zero, that's a zero. That's gonna be a zero. Sometimes we forget that. Are you good with 104?
Yeah.
All right.
Yeah,
One more thing to look at today, and that is, we are going to find the inverse of matrix A. Now, we'll do more of this next time, we only have time for one. This is, again, super simple, but it has a technique. I mean, it's got a method that you have to follow, all right? So it's a two-step process. Step one, find the determinant. Okay? We just did that. What will the determinant of this be? 5 minus -6. I got 11. Did you?
Yep.
All right, hang on to that. Step 2, we have to build a new matrix. And this is gonna seem very, very odd to you, but you're just gonna have to trust me that this is how it's done. Here's my original. Take these two numbers and we flip-flop them. So we put the 5 here and the 1 here. These two numbers flip-flop. These two numbers stay where they are, but if they're positive, they become negative, and if they're negative, they become positive. So these two flip. This is called the adjoint matrix, you don't need to know that, but these two flip, okay, 5 and 1. That is positive in the original, so it becomes negative. That is negative, so it becomes positive. Your answer is simply each of those numbers divided by 11. So 5 11ths, 2 11ths, -3 11ths, and 1 11th. That is your inverse.
That's interesting.
If by chance anything reduces, you need to reduce it. We're done because nothing reduces with that 11. That's the procedure. And that is where we will begin next time.